Welcome back to another seminar. So if you're new here, basically what this series of video seminars are is they're essentially the director's cut of the in-person seminars I do here down at Silicon Dojo in Asheville, North Carolina. So basically what I do is I have an in-person seminar here. I see what works, I see where people get confused, and then the next day what I do is I set up my camera and then I do the whole presentation all over again with a few modifications and a few changes so that folks can watch this content wherever they are. A lot of people have asked, why do I not just simply record the presentations when I do them to a live audience? And as I say, one of the things to be thinking about is when you have a camera within your environment, the camera is more of a door than it is a mirror. People think a camera is a mirror, but I'm telling you, it sounds hokey, it sounds metaphysical, but when you put things into a camera, something leaks out from the other side. And I just don't want that in the environment when I'm doing these presentations in the real world. I want the people that are here at Silicon Dojo to feel comfortable to ask the questions that they want to ask, to look stupid if they think they're going to look stupid, so that they learn. Again, the primary concern of Silicon Dojo is that each student can be the best that they can be. We're not training rock stars here. We're not training ninjas here. We're not trying to do all that. We're just trying to show our students what is possible in the technology world and give them the ability to rise up to whatever their particular level is. So the presentation that I did, and the presentation that I'm doing today, is easy, quote unquote easy computer vision using Azure and AWS. So why computer vision is easy using Azure and AWS is basically what we do is we use something called Serverless Architecture. So what happens is we essentially send a picture up to Azure or up to AWS. Azure or AWS basically visually sees that picture. The computer is able to look at that picture, and then it's able to send results back to you and tell you what's in the picture. It can tell you things like what it thinks the age of the person in the picture is. It can tell you what it thinks the sex of the person in the picture is, whether the person is smiling, a whole bunch of other information. But the really cool part about this is you do not have to build a vision server. You don't have to worry about the updates on a vision server. You don't have to worry about a hacker hacking your precious vision server. You simply pay Azure or AWS for the service. You send them a picture and they send you back what's called JSON. Basically, this is a formatting type for JavaScript. They send you back the data in a JSON format, and then you're able to do with it what you will. So what's really cool about this is you can have something like a Raspberry Pi. A Raspberry Pi can be triggered by something like a sensor, motion sensor, something like that. It can take a picture. It can send that picture up to Azure or AWS. AWS or Azure can say what's in the picture, and then you can trigger a real-world physical event based off of whatever AWS or Azure is saying. Now, this is the director's cut, so I will tell you a couple of interesting things I learned about doing this particular presentation. The first is I was going to have some custom demos of both Azure and AWS. And the reason is because Azure lulled me into a false sense of security as far as how easy this was going to be for AWS. Azure was dirt simple. Literally within an hour of setting up my Azure account, I was able to copy pasta code and getting back customized results. Literally within an hour. So within an hour, I created my account for Microsoft. I already had a virtual machine set up with Linux. On that, I installed the Python modules that are required for the cognitive services to work. I installed something called Pillow, installed a couple other things, put the code in there, and literally within an hour, I was getting custom results that I could play with, that I could hack up and do something interesting. So I created a couple of Azure demonstrations here just to show you how Azure works. So I was really excited with AWS. I was like, okay, now that I've been playing with Azure for a couple of days, AWS is gonna be easy. And then I went to do AWS. AWS has a couple more hurdles. It's easy. If you know how to use the AWS SDK, if you understand how to code for the AWS world, I am sure that Rekognition is what AWS's service is called. I'm sure that is probably not too difficult. Yeah, when I had a whole bunch of stuff to do, I only gave myself a few hours to hack some code together. Yeah, AWS was a bit of a bridge too far. So one of the lessons learned with this type of thing is if you are going to demonstrate a concept in the technology world, maybe you should just pick one product in order to demonstrate that technology with and not overpromise and say you're going to talk about a couple of different products. So basically, what I will show you today is, again, I hacked together some code with Azure, so that fully works on the Azure Serverless Architecture, but then when we get to AWS, I'm just going to show you the AWS examples, because, I'm not really sure how the AWS SDK works, and it's time for me to move on to other things, kind of how it works in the real technology world. The other thing that I realized doing this computer vision class, which is kind of disappointing, something to think about if you folks are out there are going to be doing this seminar for your students, is for some reason, computer vision apparently is not the most sexy topic in here in some place like Asheville. So how to become a YouTuber. I had 9 people in the audience. So for Asheville, that's a pretty decent number here in Asheville. For all the other presentations, I've had like 3 to 4 people in the audience. Curiously enough, for computer vision, I had 1. Again, one of the things with Silicon Dojo is I try to explain the business concepts and some of the stuff going on behind the scenes to you folks. And so just realize if you're going to do really cool things like computer vision, like this is really sexy. This is amazing. This is amazing. Yeah, again, unfortunately, you may not get a lot of people actually coming to watch the seminar. So that's just one thing to realize if you're going to do this yourself. Again, all the keynotes, all the slide presentation, and a whole bunch of other things will be at silicondojo.com on the specific page for this particular presentation. And so this is like an open source type thing. Everything that I've done today, I will put there. And if you want to do this presentation for your own students, for your own Silicon Dojo or whatever else, feel free to take my slides and modify them, edit them, or use them as is. That's all up to you. You can take the horrible nasty code that I created too. Anyway, so those are some things to think about. Those are some parts of the director's cut. And so with that, let's just dive in to easy computer vision with Azure and AWS. Well, it's easy computer vision with Azure. And then we're going to talk about AWS. That's not so easy. Like, what is this? Azure was so simple. Azure was so simple. Anyways, so easy computer vision. Why I call this easy computer vision is basically you're using something called serverless architecture. So what's really cool about serverless architecture is essentially what you're able to do is you're able to access compute services the same way that in the past you've been able to access storage services, DNS services, email services, that type of thing, right? So up on the cloud, we've got an email services for years. On the cloud, we've had storage services, Google Drive, Dropbox, that kind of thing for years. But something that is relatively new is the ability to simply tap into compute services, simply to be able to send a file to some kind of service up on the internet, and then it will be able to process and give you a result. So think about things like video encoding. So nowadays, what you can do is you can actually just send a video file up into a service like Azure or AWS. It will encode that video based off of the whatever you've given the service to encode it, and it will give you back a response. And so what's great about this is you don't have to worry about the operating system, you do not have to worry about the ports, you do not have to worry about firewalls, you do not have to worry about CPU fans, going out or anything like this. You just have your code connects to the serverless architecture, it says, hey, what the hell is this picture? And then with AWS and Azure, they give you back the data in what's called a JSON format. And then from that, you're able to parse that and do whatever it is that you want to do. You could dump that information into your own database. You could have that information trigger an event. If you see this, then do this. If you don't see this, then do this, right? Because basically it's just data coming in, just like you would be getting from a sensor. So that's why this is so easy. And again, at least for me, within 1 hour, I was able to copy pasta code like a real pro using Azure. Azure is easy. Again, 60 minutes from account creation to actually creating scripts. AWS Rekognition is easy if you already build for AWS. Again, when I was taking a look at AWS, I do not think their vision services were any big massive thing beyond any of the other services if you're already coding for AWS, but between the two if you're kind of just poking into it, trying to see what's happening, Azure is definitely a hell of a lot easier. Now, when you start thinking about vision services, one of the things I want you to remember is that Silicon Valley is diseased. Now, again, this is Silicon Dojo. I'm not trying to get snarky. I'm not trying to get political. I'm not trying to get too biased or anything like that. But one of the big problems, I've been doing technology since 1996, and there is something that has happened in Silicon Valley, in the past 10 years where they have all lost their minds, right? Society is telling these companies what they don't want them to do. The government is telling these companies to stop doing things. Everybody is telling these companies to stop, and they're not. Right? And so one of the problems you run into, especially when you start dealing with something like vision services, is a lot of people get scared, not necessarily because of how the vision services could be used, but because how they know Facebook and Google and the rest of these yahoos in Silicon Valley are actually going to be using these services. So what I would argue for you folks at home, if you're watching these videos and you're thinking about using the vision services, is don't do it the Silicon Valley way. Silicon Valley way is about grabbing all the information, correlating all this information to specific identities, tracking people all over the world, right? You don't need to do that with vision. You don't need to do that kind of creepy, I don't know how to say this in a family-friendly way, thing with computer vision. You can use computer vision in a way that doesn't compromise the morals and ethics of our society. So that's an important thing to understand. Again, I've been in tech long enough. I remember when the biography for Steve Jobs came out, and I remember in the startup world, all these startup founders read the biography for Steve Jobs, and they found out just what a colossal piece of crap a-hole Steve Jobs really was in the real world. And do you know what their takeaway was? Well, to be successful, I guess you just gotta be an a-hole. You're like, oh, no, that's not the takeaway. Again, Uber, Travis, or whatever, biography or whatever comes about him. Whole bunch of people decide, okay, the way to be successful is to be complete and utter yak ass. What I would say, again, in the real world, if you are not in Silicon Valley, don't drink their god-awful Kool-Aid. You can use computer vision in such a way that it doesn't violate people's privacy, that it doesn't have this massive creep factor. So try to build the technology light on creep factor. Think about computer vision beyond the dystopia that Silicon Valley is selling. So Silicon Valley is selling a dystopia, right? Basically social scores, tracking you 24/7, the whole 9 yards. You don't got to use computer vision that way. You don't got to connect it to other databases. You don't have to correlate it, right? There's things you can do. Think of correlations, though, versus identification. So one of the big things that people have a concern about whenever they hear about computer vision is, oh my golly, computers are going to know who I am and be tracking me 24/7. So one of the things to think about for yourself when you start using computer vision is, can you correlate things in an image to give you the information that you actually want to trigger based off of? So when I think about computer vision, one of the things I think about is kind of like a seamless security system. So imagine that you have a facility, and in the facility you have automatic locks. And so the question is you want people that aren't supposed to be in the facility to not be able to get through doors, but you want people that are supposed to be in the facility to get through doors. Now the creepy way to do this is to do specific face identification and then identify everybody's faces as they're walking through the facility and unlock doors as they go. But you may have a lot of social pushback on that. So one of the things that I bring up is, what if you triggered based off of the color of the uniform? What if for your company you pick, a pretty abnormal color for your uniform, something nice and pretty that everybody likes, but basically you put everybody in the same t-shirt, the same jackets, the same hat, the whole 9 yards. And so when somebody is walking down the hallway and the computer vision, the camera triggers, and then it sees that color on the person that's walking down the hall, it then unlocks the door because it correlates the color to being an actual employee. Is this quite as quote-unquote secure as, again, facial identification? No, obviously not. Somebody can steal a uniform and walk through the facility. But it's one of those ways you can add like a seamless type of security without putting a massive creep factor in on the situation. Again, do you need names? Do you need social security numbers? Do you need email addresses connected to images? One of the things I think about, like if I was going to use machine vision, is I think about places like Panera, right? So my wife and I used to go to Panera, and we were part of their rewards program, and so we had to have these stupid ass cards. So we go to Panera once a week, but then we've got to have these stupid ass cards on us all the time so that we could swipe this stupid card, and then we could get like 10% off of our coffee or a free donut or something like that. Something to be thinking about is, again, with things like facial identification, the computer doesn't have to care about the name of the person. The computer doesn't have to care about the social security number of the person or anything else, right? The computer can just basically assign an identification to this face. Okay, this is the first time I've seen this face, so this face now goes into the database and is associated with this ID number. And then the next time it sees the face, then it goes, okay, this is the second time it's seen the face. Again, maybe it puts like a timestamp by it. So this person comes in twice a week. And so then what you could have is you could have like a reward system where the person walks in for the 10th time that week or something, and without knowing that person's name, without knowing their social security number, without knowing their credit card number, without any of that creep, that dystopian garbage that Silicon Valley is shoving down our throats, it can just simply go, oh, this is a regular customer. We want to show them that we appreciate regular customers. And so the computer can simply pop up, hey, give this person a bagel. This person. Not Bob a bagel, just okay, in our database, we know this person has walked in so many different times. These are the things to be thinking about with computer vision. This doesn't have to be as just insane as the Valley wants it to be. The less data you create, the less data you are liable for. Again, the more images that you take, the more you correlate that with other databases, the more you then put that into your own database. If your system gets hacked, all of that data that leaks out, you're going to be liable for. If you don't grab that data in the first place that you probably don't need to begin with, then you're not going to be liable for it. And the other thing too is, at the end of the day, is think about storing hashes, not images. Hashes isn't the right word. Oops, I should have gone back and changed that word before I did this presentation. Oh well! I'm just a normal person. What I mean by this is a lot of people think that biometrics work off of the actual face or the actual fingerprint, right? So 20 years ago, I was working on a project for biometric sensors for a data center that I was helping build out. And one of the big concerns everybody had is, I don't want the company to have a picture of my fingerprint. Now, you know, whatever, right or wrong on that particular argument. The curious thing is, once I actually started taking a look at our biometric systems, the fact was they didn't actually take pictures of the fingerprint. They didn't actually take a full image or a full whatever, vector of the fingerprint. Essentially what happens is when you put your fingerprint on the sensor, the fingerprint is looking for very specific things. There's things called whorls, so whorls and ridges and all these types of specific things on a fingerprint, right? And basically what it does is then it just figures out mathematically, okay, this whorl is this far from this ridge, and you got, 5 ridges from here to here, and it basically just figures out a little bit of math there for basically how to explain that fingerprint in math. And so when somebody puts their fingerprint down again, it scans for whatever features are on that fingerprint. It creates a new little number. It then associates that number in the database, and the database says, yes, we have seen this number before, and so it lets you in. And so the important thing to realize here is that your fingerprint on the sensor then creates essentially that hash. But from that hash, you can't recreate a fingerprint. All it's telling you, like theoretically at most, is where some of these whorls and different things are. You can't actually recreate a fingerprint from it. Again, the same thing is true with facial recognition. So with a lot of these facial recognition systems, they're not taking a picture the way that you think they're taking a picture. Essentially what they do is they look at the face, and they try to find prominent points on the face, and then they do math, and they basically do measurements. How far this point is from this point, and 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 how it right? And then basically when you go in front of a camera again, it does all of that math. It then compares the output of that math to whatever's in the database, and then it says, oh yes, we have seen this particular person before, and whatever event triggers. So one of the things to think about is this is a very useful thing for these very large technology companies, because storing the equivalent of a hash doesn't really require much storage, right? Again, you're just storing numbers, letters, numbers, that kind of thing. Kilobyte or something. Remember, a full image is going to be megs. And so if you think about, a world where we have 8 billion people, and then you think about taking, thousands of pictures of people every single day, that becomes a massive storage concern really quick for these large infrastructure as a service companies, AWS, Azure, that type of thing. And so all they do is they just keep those hashes, and so their storage costs are relatively minimal because they're not actually taking the full pictures. One of the problems you can run into, though, with people deploying new systems and using something like serverless architecture is they might decide to store the images. So again, remember, you're liable for whatever you store. If you simply have your system take a picture, send it to Azure, get the results back, and then flush, basically delete the picture, and then you're not liable for a lot. If you keep all of those pictures, you keep all of those images may have other things in them that people are worried about. So let's say you have a boy going out with another boy and people don't know that they're gay, or a girl with a girl, or who the hell knows what. Imagine if a hacker gets into your system and they are able to access your image store and be able to download all of those images, and now they have pictures that people may not want out in the world. People are having affairs, people are homosexual, all that kind of crap, right? That is a massive liability concern for your company. Whereas basically if you take the image, you send it up, you get the results, you delete the image, once that image is basically ground into nothing, then you don't have to worry about that getting out and there being liability. So these are some of the things that you really need to be thinking about if you're going to be using computer vision services for your company. Because again, they're so easy that dumb people can build infrastructure using them. The other thing to be thinking about with this is algorithms do not replace management. One of the big problems you get with computer vision is, again, we hear a lot about this nutty stuff going on with Amazon and that type of thing, where basically people are being punished based off of what the systems are seeing, and then what the systems supposedly see. That then triggers ramifications for the actual employees. One of my problems whenever I talk about this is, believe me, I want computer vision. For Silicon Dojo, if we grow as big as I think we can grow, if we have employees, the whole 9 yards, I am going to be using the crap out of computer vision. But here's the thing, I want this as an ancillary, I want this as a tool for management, not as a replacement for management. Again, like things that I have to worry about with something like Silicon Dojo, I would like this to be relatively an all ages facility. Again, I have to figure out, what all ages actually means, but let's say it's from 12 or 13 all the way up to 60. Well, if I have from 12 to 60, the reality is probably some of my assistant instructors, when I start hiring assistant instructors, right? When you hire assistant instructors, who you're probably going to hire? 20-year-olds, 18-year-olds, 19-year-olds, those types of folks. And then if I have students that are here, and some of those students might be 15 or 16 years old. Now, as humans being humans, it is completely understandable that a 19-year-old might be attracted to a 16-year-old. Here's the thing. Not quite sure how it works in Asheville, in North Carolina. But here's the deal. I don't want to be liable for any of that crap. I am trying to run a liability light company here at Silicon Dojo. You do you. That is consensual. That has nothing to do with Silicon Dojo, right? So one of the big concerns, though, especially when you have young people, you have one young person teaching another young person, and they start making googly eyes at each other. Then all of a sudden, they start working more one-on-one, and this can cause real issues in the real world. And so what would be nice for me is if I have a single pane of glass, it can kind of show me where my instructors are and who my instructors are dealing with. And if I have one instructor, and that instructor, let's say, deals with on average 20 different students per day, and they're relatively gender mixed, right? Probably gonna feel pretty comfortable with that. On the other hand, if I see another instructor, boy or girl, which way, and basically they're dealing with on average 5 students a day, and the gender of those students is completely opposite to what they are, that's one of those things that, again, from a management standpoint, I may just want to walk over. Hey Tim, how you doing, Tim? So I was looking at my single pane of glass, and I've been noticing you seem to really have a certain gender of students that you're dealing with, and I just want to have a little bit of a conversation here so that as a boss you understand the concept of liability and where I'm coming from, right? one of the big things with these types of systems is to think about this as tools so that managers better understand the environment that they're dealing with. Again, I'm one of the people that actually, I hate to say social justice, but again, like when I talk about wanting diversity in Silicon Dojo, I really believe this. Like, again, 51% of the population is women. If we have no women, that's a little weird. Currently, it's a little weird, right? But we should have women. We should have different races and ethnicities. Silicon Dojo, I would hope at the end of the day, horseshoes and hand grenades, it looks like a decent amount like the demographics here where we are in Asheville, North Carolina. One of the big problems you can run into, though, is the metrics that you may be using for looking at things like diversity may not be accurate in weird ways. So one of the things that I've noticed for Silicon Dojo, and I'm still trying to figure out what the issue is I have women that sign up for Silicon Dojo that don't show up. I've had one woman show up so far. Right? Now think about this though. As a manager, worrying about diversity and all that kind of stuff, once this organization gets bigger, once we have more employees, one of the problems that you can run into is when you're looking at just simply things like sign-up forms or whatever else, it may give you a false sense of accomplishment, right? If I have 50%, let's say, women and 50% men, I may look at that and go, okay, that's relatively balanced, or 40% women and 60% men, or something like that. Okay, that number makes sense. But the issue is what happens if those aren't the people that are actually showing up? What if they sign up, but they don't actually show up? Right, that's where the metric and what the manager needs to know can be a disconnect. So if I can have computer vision in my facility, basically just continuously analyzing what's going on in the environment, I can see, okay, well I had this many, let's say, women sign up to come to Silicon Dojo, but out of all of the images that were taken, it's only 10% women. That's one of the things you can sit there and you can look at it and you can ask yourself, okay, why is that? Or again, like I say, from a management standpoint, what if I have women that come in till, let's say, 6 o'clock at night, and then let's say we're open from 6 to 9 at night, and they basically all leave at 6 o'clock. Right? That is a signal to me to say, wait a minute, why are all the women leaving at this time period? And then you just go and you have a conversation. Is it a teacher making them creeped out? Maybe the evening staff for some reason. There's some weird thing going on there. Maybe they don't feel safe where Silicon Dojo is. It's like, well, Eli, we like the place, but there's not very good lighting. We feel like this is a bit of a remote area, and so we feel safer by leaving earlier. And then again, from a management standpoint, that's information that I can then use to try to figure out how to make the facility better based off of what we're trying to do. So the important thing to be thinking about this is with the algorithms and with computer vision, this is supposed to give you more information to become a better manager. It is not supposed to replace you as a manager. We have a lot of people in management positions that, let's just say, they don't have the most courage of the humanity, and so what they try to do is they try to foist their management responsibility off on algorithms, and it goes poorly all the way around. Use vision to give insight into your business organization. Don't use vision to trigger decisions. Vision should not trigger a decision on discipline or firing or anything like that. It should just be some information for you to be thinking about. Be able to explain what the vision system does. What is the vision system doing? Why you designed it this way. Why is it designed this way, and what it's looking for. So again, if I have a security system for Silicon Dojo, and again, I want it to be a kind of seamless security system, and I'm sitting there, I'm like, okay, I know people are going to be creeped out by faces, so I'm going to trigger it off of clothes. So why do we have this system? We're trying to improve the security of our facility because we don't want random homeless people just wandering through our facility. Why did we design it to trigger off of clothing color? We decided to trigger it off of clothing color because we knew people were going to be creeped out if we did facial recognition, and so clothing color seemed like a good correlation for people that are supposed to be in the facility. And what's it looking for? It's looking for that specific clothing color. If you were able to say something like that, it's a lot easier to deal with the end users, it's a lot easier to deal with your employees, and it's also a lot easier to find out if there's problems or if you've made assumptions that are incorrect. Again, remember, in the technology world, we don't all believe what the narrative tells us we're supposed to believe. You may have a whole bunch of people in your Silicon Dojo that are like, I don't care if you take a picture of my face. Everybody already has a picture of my face. Why why the hell are you correlating this crap of a clothing color? You could just take a picture of my face. It would be so much easier. Again, coming from the Baltimore area was very interesting. We had NSA up there plus all those government agencies. People up in the Baltimore area were far more comfortable with things like biometric security systems. Again, I was just sitting there like, oh, you don't care about any of that. Oh, wow, right? So again, if you can explain all this stuff, you might find out people are creeped out or are not creeped out. You can try to figure out what's going on. Create rules based off of whatever these systems are showing, and don't take knee-jerk reactions. If your employees do things that you are surprised that they're doing, it didn't even come to your mind, because that's the real world when you're dealing with employees. You're like, what? I didn't think they were going to do that. Don't come to a knee-jerk reaction. Have a rules-making process, and then basically warn the people that they're not supposed to do that. Then come up with the specific rules, have everybody sign off on it, so everybody knows what is going on, everybody understands the system. Again, one of the big things to understand, that when you have employees are very much like cats. If you scare one of them, all of them go running in different directions. I know, I'm not supposed to talk about employees this way, but I've had enough of them. I have written enough checks for employees. I'm allowed to say this, by God. And so one of the things you have to think about, right? A lot of managers feel really smart. A lot of managers, because it's like, yes, I'm not going to be responsible for this anymore. I'm going to hand it over to the algorithm. And then the algorithm starts doing whatever the hell the algorithm and like it's not necessarily built the way it's supposed to be built. And all of a sudden employees start getting punished for reasons that they don't really understand why they're getting punished. And then everybody starts freaking out. Remember, when you have a business, when you have an organization, everybody is important to that organization. Oh, that minimum wage employee, they're replaceable. Yeah, but are they replaceable by the dozen? Like, you really got to be careful with that kind of stuff. So this is just something to be thinking about. Again, when I used to install digital surveillance systems, one of the stories I tell is one of our clients dealt with mentally handicapped, let's just say, children, young people, teenagers, young teenagers. And so they had like a nursery school type of thing. And so you had kids and wheelchairs and all kinds of stuff like that. So anyways, we installed this digital surveillance system 15 or so odd years ago so that the CEO could have a better understanding, a real-time understanding of what was going on in his environment. And it was the biggest pain to teach him how to use a system, because I swear you, we had installed this beautiful system. I'm sitting there explaining for him how to do stuff, and then like every 2 minutes, he was like, well, hold on, Eli, hold on. I told you to move that kid like half an hour ago. I see that kid is in the exact same position. Move that kid now. And they'd sit there, you'd watch a kid get moved. Okay. And I'd be sitting there explaining something. Oh, well, hold on, Eli. Has that kid gone to the bathroom? And it really was. It was like this guy actually being able to have a real-time view of what was going on in his environment. And yeah, he was kind of surprised what would happen. So if you do start implementing computer vision or whatever in your environment, again, bring it in slowly. Remember, if you scare your employees, things can go poorly. One of the big things to be thinking about when you're using computer vision, or a lot of stuff going on in the technology world right now, is that we're looking for general direction, not precision. So the big thing with computers up until recently was precision. 2 + 2 = 4. 5 + 5 = 10. Really long, nasty algebraic equation equals whatever the answer to that algebraic equation is. In the modern world, we are getting so much data. We are getting so much data, and we require decisions to be made so quickly that we're going more for a direction than a precise answer. So I think about this. So I interviewed the CEO of D-Wave a couple of years ago, and actually went to D-Wave last year, and he was talking about quantum computers. And so basically the idea he was talking about with D-Wave's quantum computers is that the answers that their quantum computers were giving is like the idea of a direction. A pretty good way to go. Like you want to go to the 4-ish direction. If you have 2 + 2, go 4-ish. Might be 3.5, might be 4.5, but you kind of sort of want to go in that direction. He was talking about they were doing an experiment with taxi drivers in Beijing and actually having real-time GPS systems. So the taxis run around, and then not only would they grab their GPS locations, but then it would also see what the traffic conditions are. And so literally turn by turn, it would be adjusting however many thousands of these taxis were in Beijing, the idea of making the system more efficient, more cost-effective, and the whole 9 yards. Well, the thing is, when you're dealing with thousands and thousands and thousands of cabs and you're making second by second decisions, there is just not enough compute power to actually give the precise answer at any one time. So it's kind of like they just want you to get going in that direction. If they can get people going in better directions, if they can get the Beijing drivers driving just in better, right, is better for the overall system. The same is true when we start dealing with computer vision. Because a lot of people want to be egotistical as far as computers are concerned. How does it know what my age is? Right? They start flexing on the computers. Oh, you think you know what my age is? Oh yeah, tell me my age. It's like, oh crikey. It's a computer. It's a computer. This is not telling you that you're 43 years old in 2.5 months or something like that. The idea here is, if you're going to be showing an advertisement to somebody, let's say you have a billboard, somebody's walking by the billboard, do you want to show them an alcohol advertisement or a Tonka trunk advertisement, right? If the person in front of that billboard is, I don't know, somewhere between like 5 to 12 years old, you're going to show them a Tonka trunk. You don't really care if they're 9 or 5 or whatever else. You want the age range. Right? If somebody walks by and they're somewhere between 21 and 51, then you might show them Bacardi, right? You're looking for a direction that you want to go in. Basically, out of all the things that could occur, a better way of doing something, a better way of triggering an event. So when you think about dealing with things like computer vision, this is not about precise. It's not about this is somebody who identifies as a woman and is 45 years old and is 201.5 pounds, blah, 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 blah. It's like, it's just trying to horseshoes and hand grenades with this information. One of the other big things to think about too is, do you know what you're looking at? Again, a lot of people make assumptions. One of the interesting things when you start looking at technology and you actually start looking at statistics and all that is a lot of your assumptions are wrong. You think the world is a way that it isn't. When the computer starts giving you responses that don't line up with your worldview, it's very easy to think there's something wrong with that computer. The reality is, you may just not understand how the world is actually currently working. So vision has not been about being precise, it's about giving a direction, horseshoes and hand grenades. Should you show an ad, again, for a Tonka truck, a Barbie doll, a Ford F-150, or summer dresses, right? So again, if you have, a male in New York City who is between 40 and 60 years old, and they are in, I don't know, fancy clothes, Patagonia, whatever, maybe you want to show them, an advertisement for a Mercedes or a Tesla. If you have a kid walking by and, I don't know, somewhere in Oklahoma, you may want to show them a Tonka truck. That's what we're going for here. The next thing that comes up is a lot of people get snarky, especially since I do videos on YouTube. Oh yeah? How does the computer know what that person identifies as? What if they identify as whatever? And that's actually an interesting question. Again, remember, as technology professionals, right? Those people get to laugh that off and be snarky. As technology professionals, we have to try to figure out an answer to that question. What if the person does identify? Like, what if the person identifies as something other than what the computer comes back at? And then one of the questions you have to ask yourself is, do you really understand the people that you're trying to sell to, or do you really understand your customer base, or your client base, or your employee base, and the whole 9 yards? One of the things to be thinking about, again, with things like identification, is this statistically relevant for you? So I think about this coming to Asheville, North Carolina, right? So we're down here in Asheville, North Carolina, and there are a lot of folks that seem to be transgender. I am not going to label anybody, but there are a lot of people that I would think of as boys who wear dresses. Again, not being snarky, just true. There's a lot of makeup and dresses on folks that have hairy legs. Am I allowed to say that? That type of thing. There's a lot of folks in that persuasion. I have to say, coming from the Baltimore area though, it wasn't the case. We had a lot of African Americans up in the Baltimore area. We had a lot of gay people up in the Baltimore area. But transgender people weren't something that you saw on a daily basis. It was like a very one-off event. Again, here it's it's daily. It's daily, right? So one of the things you have to ask yourself is when you have these computer vision systems and we start talking about things like self-identification, does it actually matter for your implementation? Again, let's get past societal crap that's going on. Let's get past about how people want to be. Let's just talk about it realistically, right? If you're in a city, and let's say Oklahoma, that is very very old school, conservative, I would say, whether people want to wear dresses or not, if they don't, then doesn't really matter to your system, right? If people operate off of the classical identification systems, then for you, it probably doesn't matter how people quote unquote self-identify. So that's one of the big questions to ask yourself whenever you have one of these systems. And then the next question to be asking is, are you making the relevant correlations? When you sit there and say boys should buy X and girls should buy Y, do you realize that nowadays there really is fingernail polish for boys? I'm not talking about the goths. I'm not talking about the goths from my generation that would go into Forever 21 and say that they're buying a nail polish for their sisters or whatever. I'm saying there's actually a real nail polish out there for boys. So when you're thinking about showing an ad or when you're thinking about doing something else, one of the questions to ask yourself is, does the world correlate the way you think it does? Should you be showing nail polish to girls and jeans to boys? Or should you be showing nail polish to boys and jeans to girls? Right? Again, there's this whole, that thing. We actually have a friend that used one of those things. It allows women to pee like guys. She said it's horrible. If you thought about buying one of these, our friend says this is a horrible idea. All kinds of nastiness there. But again, it's just to show you that, again, how you think identities, operate in the modern world may actually be different. And when you think about the correlations, you may be thinking about things not quite how the real world operates. So these are some of the things just to be thinking about when you're dealing with this whole vision system. Now we're talking about serverless architecture. So again, serverless architecture is really awesome because basically I don't have to worry about their operating system. I don't have to worry about their antivirus. I don't have to worry about their CPU fans failing. I send them data, they send me back results. It's a great, wonderful thing. Also, one of the nice things with serverless architecture is you have no idea what's going on that side. And so the great part is they can upgrade, they can modify, they can make things better essentially on the fly. And it doesn't really matter to you, right? You have your secret, you have your endpoint, you feed it a file. They upgrade their systems on the other side. You just get better output, right? You don't have to worry about any kind of upgrades or anything like that. So essentially, how Azure or AWS works is what you'll do is your server. So with Azure, what I have is I have a LAMP server, Linux, Apache, MySQL, and PHP server that also has Python on it. So basically, I have a Python script. The Python script will point to an image that is publicly accessible with the particular script that I have, and it will go to Azure server and it'll say, what is this image? Azure server will then look at that publicly accessible image, and then it will return back in what is called JSON format. That is Will Smith. They are male. They have a smile. They have a beard, so on and so forth. That then comes back to your server as that JSON response. From there, you can put that into a data store. So when I talk about data store, you can put that into a file. So I'm dynamically creating a file, an HTML file, when I show you the demonstration. You can do that. You can put it into a database of some sort. You can do an if-else. Basically, you can scan through what the response is, and if something is seen, that can trigger another event to happen, so on and so forth. But the important part here is all the processing is occurring here. Basically, you have like a 30-line Python script that connects to Azure server, points to the image, and then it just responds back with what it sees. So from there, let's actually go and take a look at a couple of demonstrations. So this is Azure. We will take a look at Azure in a bit. Again, Azure is cool. Rekognition. This is Rekognition. We'll take a look at Rekognition in a bit. Again, very cool, but far more complicated than Azure. If you're looking for a nice, simple, easy solution, go for Azure. They're not giving me any money. I'm just saying in 60 minutes I had Azure up and running. In 60 minutes, I had a bit of a headache when it came to recognition. But anyways, you can go. This is computer vision, so it's a cognitive, what's called a cognitive service for Microsoft Azure. And if you can come here, it gives you some basic information when you go to their page, and it also gives you some demonstrations here. All right, so basically with this demonstration, is showing you what it sees in this particular image. So this is a subway line, basically a subway tunnel. It's able to see a subway train, it's able to see a person, it's able to see some of this information. So it says the objects, so it's telling you the objects and the coordinates in the picture where it sees the object. It sees a person of a confidence of 76%. It sees another person with a confidence of 62%. It sees a subway train. It says a land vehicle, confidence 92%, so on and so forth. Then it comes down here and it shows you what the tags are. Train, platform, station, indoor, subway, clothing, pulling, the whole 9 yards. And you can scroll down, gives you some more descriptions, tells you what the image format is. It tells you if there's adult content there. So if you want some kind of system to go through, make sure you don't have adult content, or make sure you do have adult content. I mean, hell, if you're trying to create a competitor to Pornhub, you know, you don't want pictures of flowers on your site, do you? Tells you what the adult score is. So again, if the content is too adult, whether it's gory, whether it's racy, some categories. And here is what's cool is, again, it shows you colors, right? So dominant color background is black, dominant color foreground is black, and accent color is 484C83. So again, this is one of the things to be thinking about when you use computer vision. So many people focus on the biometrics of the face. It can see a whole bunch of other stuff, and then you can trigger events based off of these different things. Let's say if we click on this particular image here, again, you can see, so it finds the 3 people, it finds a whole bunch of different stuff. So object footwear, object person, object laptop, so on and so forth. And so this is basically kind of sort of what the JSON format looks like when it comes back to you. So let's go over and actually look at an example that I created. So this is my, example. Oh yeah, anyways. I created an app. It's an app. Basically what I do here is, what does the computer see? The URL is, so we plug in a URL to an image, we hit submit, and then we click see results. So if we go down here, I don't know, let's do Idris Elba. Been interested in Idris Elba. Like, I don't know, for some reason, like, you just start doing things, and for some reason you start looking at the same person or whatever. So Idris Elba. So let's grab a picture of Idris Elba and see what it says. Okay, so let's grab this. I guess that's Idris Elba's wife. I don't know. Copy image address. So you copy the image address. So we go here to the URL, and then we paste. Make sure there's like a little JPEG there, then we hit submit. So you'll notice this takes a second. If it takes a second, it's actually working. If it goes that quick, it's not working. So for the image processing, it takes anywhere between like 1 to 2 seconds, just something to realize. Again, on scale, that might actually matter. So if it goes boop, done, that probably means it didn't actually work properly. If it kind of slowly does what it's supposed to do, then hopefully it's worked properly. Now from here, we can go and click on see results. And so this is what we got here. So I will enlarge this a little bit. So we have the picture. So I just embed the picture that we're supposed to be looking at. Idris Elba and woman posing for a picture. So that's the description that was automatically created by Azure. It's a category, people group with a confidence of 67%. Tags, person, human face, clothing, suit, smile, man, formal wear, blazer, premiere, shoulder, dress, woman, event, standing. So basically, it just pulls out all of these tags. These are things you could try to tag the image off of. Again, for correlation, like if you're going to create an image database and you want people to be able to search through the image database, again, these may not be the greatest tags in the world, but they might be something that you can use for actual text so people can do searching. And then faces. So faces, it says male of age 56. So it says Idris Elba is probably about 56, which, I don't know, probably right. Horseshoes and hand grenades. At location, 1193, 197. So basically 1193, that's 1193 pixels from the left, and then 197 is 197 pixels down. So basically it's saying right here is basically where that guy's face starts, and then the rest of these coordinates allow you to create a little CSS box. Then you have female, age 27, at location 673, 269 down, and so 673 this way, and 269 down. That gives you her face, and you know, she's, I don't know, is she 27? I'm not gonna guess at a woman's age. Well, we ain't even gonna try to do that. Let's try to see, Brad Pitt, let's say. Pull somebody else up. Okay, we grab this image. Brad Pitt and Angelina Jolie. Again, we go to copy image address. We go here, we click on back. I then dump them in to that little thing. We hit submit. We'll see if this works. Okay, it's taking a second. It should work. See results. Okay, yep, it did pull up the image. There are some of these images now, they have these weird copyright blocks. I'm not actually sure how the copyright block works on the internet, but anyways, they have some copyright blocks, so sometimes it'll fail out because they have some kind of copyright protection. That's why I wasn't quite sure. But anyway, so we have Angelina Jolie, we have Brad Pitt here. It tells you, Angelina Jolie et al. Informal wear. Aw, poor Brad Pitt been canceled. Azure's like, I don't know, is Angelina Jolie there? Again, this is an interesting thing to show you though. Like, it picked out Idris Elba, it picks out Angelina Jolie, but Brad Pitt, I don't know, some guy on her arm. Again, just something to realize with these kinds of things. They're not specific, they're not, you know, as accurate as you may think they would be. People with a confidence of 50, 7.8, people portrait with a confidence of 42.58, and then human face, person, suit, clothing, man, formal wear, smile, fashion, bow tie, blazer, gentleman, lipstick, fashion, makeover, lady, lip, woman, posing, indoors. All right, so you can use those for tags. Male, age 50 at a location 980 by 166, and 980 by 166 gives you Brad Pitt. That's been canceled. They say he's 50, female, age 37 at 272 by 152, 37 by 152. I don't know. I'm not going to argue. Again, horseshoes and hand grenades. Horseshoes and hand grenades. So basically, this is a very little simple app that I created. Essentially with this I have a little form. With that form it submits the URL that I've given to the Python script. The Python script then sends that up to Azure. Azure then sends a JSON response back, and then basically what that Python script does is it dynamically creates this web page. So Azure result.html, Python dynamically writes that web page, basically embeds the image that we're taking a look at, and then writes description and whatever the description is, category, whatever the category is, tags, loops through all the tags that it finds, faces and demographics, loops through those. So this is a basic example there. Then I have OCR. So I created this little OCR app, and this is really cool. So OCR is optical character recognition. Basically, the computer can read. And I have to tell you, the computer actually can read pretty well. So if I just do something like text, so let's try to find text. So a lot of times there's like pictures of text. I don't know, notify text. Okay, so let's do copy image address. So that's a text that came in for, I don't know, Washington Department of Health or something. We can click this here, we can do paste, we can hit submit. It's taking a couple seconds, so that should have worked. We go here, and then I do the refresh. Oops, no, that did not work. Okay, let's go grab another text. Again, sometimes it fails out. Sometimes it fails out. Again, I think there's like some weird copyright protections on some of these images, or sometimes, you know, Azure just may fail. Okay, we do paste here, we do submit, taking a second, ooh, that looks good. Okay, then we're gonna go here, we might have to refresh. Okay, there we go with refresh. So this is the new page that was dynamically created by the Python script. So this shows the text that we are trying to read. And basically, it's Emma, I try to call you, but signal bad. Text message, day 15, it's Emma, I try to call you, but signal bad. I have been taken to the hospital after, you know, having a fall this morning, blah, blah, blah. So this is literally Azure on the fly being able to read the text in this particular image. We can go over and we can do something like a restaurant menu. So back when I thought I was more motivated for this project than I ended up being, one of the examples that I was going to give is I was going to take pictures of menus in the local area, have the script run through, read all of those menus, and then dump that information into a database. And the reason that you could do that is then you could actually do a search for different types of food based off of what's in that database. So if you wanted Wagyu hamburgers, you could type in Wagyu hamburgers. All of the menus would have been scanned by OCR, the results would have been dumped into a database, and that's a very simple select SQL statement, select where in the MySQL database to basically then show you any menus that have something like Wagyu hamburger in it. I was going to do that, and then I realized I was going to take more time than I cared about. But that's one of the cool things that you can do with OCRs. Again, imagine, let's say you want to create a tourist site, but you don't want to put that much effort into it. So again, you go to all the restaurants in your area, you take a high definition picture of all of their menus. You have Azure OCR scan the menu, dump the results into a database, and then somebody could search. So again, my wife is vegan. So if my wife wanted vegan food or a specific vegan food, she could type in vegan, and then it would literally scan. You could, since all of that information was stored in a database now, you could basically do a select where statement off of whatever's in the database, and any menu that had the word vegan on it could then be displayed for her to actually take a look at. And so that's one of the ways that these kind of systems can be very powerful in ways you may not have thought about. So I don't know, let's click on this particular image. So lunch menu special, garden salad, Caesar salad, poulet grill, whatever else. So we're going to do copy image address. One of the things you will notice is formatting for text can be a bugger. It can read the text, but it can give you some very ugly results. The text will be accurate if you can figure out what it means. Okay, that looks like it took a second, so let's go here. And okay, so this is the menu that we submitted to the OCR. Lunch special menu, side order. Okay, see, that's the thing. So lunch special menu, side order, garden salad. So when garden salad, house salad, coleslaw. Then it said $4. Then Caesar salad, potato salad, macaroni, $4. Poulet grill, $7. So you'll notice it was actually able to read this document relatively well, but when it gives you the text output, it's just spitting out everything it's seen. And then one of the issues that you have to deal with is when we think about parsing, so many times we think about parsing files, we simply think about being able to read what's in the file. A lot of people don't think about, okay, yeah, but then how do you present it back to a user in a useful format? And that's why I was saying, I was thinking about doing something like a database where it would just search the database and then it would show you the image of the menu. Right? So that way you're not trying to dynamically rewrite the menu where you've got to worry about how to actually format that menu. If you just simply show the image of the menu, that solves some problems for you. So that's basically what Azure Vision does and how this stuff looks once you've actually got it running. Like I say, I think it's really, really cool stuff. Beyond that, there's a lot of additional things. There's a lot of additional things Azure Vision does. It'll look for logos. It'll do face identification. So it does do face identification. So you can take a picture of somebody's face multiple different times, and then basically you can have that be compared against the database and then show you all of the other instances where that person is in the database. So again, you could use this for something like a security system. You could use this for all kinds of different things. Basically, if you have lots of let's say you're doing genealogy, right? So you have genealogy, you have lots and lots of pictures of all of these different people. You don't really know how to index them. You scan them into the computer, but then how do you show all of the pictures of your great Uncle Bob? That could be a real pain in the butt. Well, if you scan a couple of your pictures of Great Uncle Bob, you then identify Great Uncle Bob, and then basically you have Azure go through and say, in any of these other pictures, find a face that looks like Great Uncle Bob. That's one of the ways that you could then tag all those different images. So you can do that type of thing with Azure. Color detection. Again, this is how you know how geeky I am. I'm a real geek. Again, other people are all worried about facial recognition and all that crap. I think color detection is awesome. If you really think about color detection and how you can use that in business environments, there is so much awesome stuff you can do here. Again, think about for retail environments, so clothing stores, that type of thing. Imagine, let's say you create a wall that's white or some color, so you know what that color is, and so basically you can eliminate that if the computer comes back with that color. And then somebody walks in front of that wall and a camera takes a picture. That camera can then look at the color and then determine what the color is using the Azure function, and then you can have a digital display that would then start showing images of other clothes in the same color palette as what the person is walking by in, right? So most people have their favorite colors, and if you have your favorite color, there's probably good accent colors. So imagine having a fashion boutique, especially a fashion boutique where there are not a lot of people in there at any one time. Again, as I say, I like Ralph Lauren. You may not realize it. I like Ralph. Anyways, right, you go into a Ralph Lauren boutique, you go to the mansions up in New York, there's not necessarily a whole hell of a lot of people walking through that place, right? So if I have a shirt on, if I have clothes on that I like, and I walk into the Ralph Lauren mansion, if the Ralph Lauren mansion takes a picture, essentially looking for what I am wearing, looking for the color scheme, and then all of a sudden the displays in the retail area start changing to models that have clothes on within the same color palette that I'm wearing, that makes sales a hell of a lot easier, right? Color detection, I think, is a really fascinating thing to be thinking about, and it's one of those things that's literally just so simple, nobody thinks about it. You don't think about using color detection as a security system. You don't think about using color detection, for retail sales, that type of stuff. I think there's a lot of interesting correlations you could use with color detection. But, that's just me. Beyond that, as far as Azure goes, they also have something called spatial analysis. This is awesome. This is cool. This is cool. This is cooler than color detection. This is cool. And this I'm not showing you a demonstration of, because it's a bugger to set up. Basically, with spatial analysis, you can have Azure in real time analyze your video feeds. And so basically with this is trying to show like a line at a grocery store, and it shows basically what the wait time is for different people. And so it can dynamically show you how long people are waiting in line, again, at something like a retail store. So if you have two lines are open, basically you can have spatial analysis looking at the lines. When it gets to the point that the spatial analysis thinks that the wait is going to be like over 5 minutes or over 6 minutes, it can then essentially, you can have a script that would then, SMS page the manager and say, hey, get somebody else to open up another cash register line. You can do something like that. Again, when we start talking about large institutions, we start talking about large companies, grocery stores, whether it's Safeway or down here we have Ingles, Walmart, or whatever else. Again, the corporate folks, CEO folks, I know we're not supposed to talk about those people, but I will. The executives for the corporation, they want to know how well each individual store is actually being run. So if you have like the spatial analysis system set up, and they can see which stores are being managed efficiently, which stores are not being managed efficiently, essentially where are the stores where there's never a line over 5 minutes, and where are there stores where 25% of the time there's a line over 5 minutes, right? The executive level, the managers can actually be able to see that kind of thing in real time and hopefully be able to make some better management decisions based off of what's occurring. Again, remember, with all of this stuff, this is a single pane of glass. This is supposed to give you analysis to make better management decisions. So you have somebody at corporate call Walmart, the Walmart manager, and say, hey, we see that your lines are over 5 minutes long, 25% of the time. What's going on? And then the person can say, look, we just had, 6 people, go out sick with COVID or whatever else. I don't have enough people to man the registers, so that's why the registers are too long. And then the manager up there hopefully can say, okay, well, we give you authorization to pull in employees from other stores to try to be able to get everything working properly. Yeah, this is some really cool stuff here, and again, it's amazing that, again, rather simple. Like with this, why I'm not showing it off here is, one, I'm not really sure how I could demonstrate it in my environment, but basically you have to have the surveillance camera, and then you have to have an endpoint, so you actually create a little endpoint server, and the endpoint server and the surveillance camera kind of have to talk to Azure, and Azure has to be able to send back a response so that you can do something pretty with it. So it gets a bit complicated, but it is one of the really cool things that you can do. If you're looking at Azure, one of the things to realize is Azure, once you get into the dashboard, can be a bit complicated. So again, for somebody like me, I remember back when infrastructure as a service was pretty simple. They had things like compute and storage. That was about it. It was really easy to understand what's going on. Nowadays, whether you're doing with Azure, whether you're doing it with AWS, they have hundreds of services. Simply trying to figure out what frickin' service that you're looking for can be a real pain in the ass. So just something to realize. Nowadays, these companies will have certifications for their platforms. AWS has certifications, Azure has certifications. This is not a joke. This is not a waste of money. At this point in time, these services are becoming so complicated that having a certification in these services is not the worst idea out there. This was probably one of the most complicated things for me, setting this whole mess up. Just trying to figure out where the hell the Vision service actually was. So basically, you go into Azure. So you have free accounts for at least a year. You have a free account as far as Vision is concerned. You can do 20 requests per minute and 5,000 requests per month. So for demonstration machines, that should be more than enough for you, and that's all completely free. So you can sign up for the free service. When you do, the first thing that you're going to need to do is you're going to need to create what's called a resource group. So the resource group, basically, and again, this is one of the reasons I like Microsoft. A lot of people don't give Microsoft enough respect in the modern world of technology. They're all like Apple or Amazon or other things. Microsoft kind of stays under the radar because they're focused so much on the enterprise world, but this is the kind of cool stuff that they do in the enterprise world that's absolutely wonderful. And so essentially when you set up some kind of infrastructure, you could be doing a lot of things. You could be doing vision analysis, with voice analysis, with storage, with messaging, with a whole bunch of stuff, right? You may create some kind of essentially application that uses a whole bunch of different services in Azure. The issue that you're going to run into in the corporate world is basically how does that all get built out? The CFO does not want to see $1 million per month bill to Azure. That doesn't help the CFO a lot. What the CFO wants to see is, okay, this particular project is costing $10,000 a month. This particular project is costing $5,000 a month. This particular project is costing $100,000 a month, those types of things. So one of the cool things is when you have these resource groups is you can have things like cost analysis, you can have cost alerts, you can have budgeting, you can have advisor recommendations. So again, this isn't what the kids like to hear about. The kids never want to hear about budgeting. What do you mean budgeting serverless architecture? Ridiculous! I should be able to use as much as I want. That's great. That's not how it works in the real world. So one of the cool things here is basically you create a resource group. And so in that resource group, you put all of the resources. So I'm using the cognitive services here for the vision. And then all of that gets lumped into the group. And then for security, for policies, for cost analysis, for alerts, for access control, then what you can do is you can set all of these parameters for the resource group, right? So again, you can have one resource group set for automatic security policies. You got another resource group set for retail display systems, the whole 9 yards. So once you do that, then you're going to add what you need. So we're looking for the Vision Cognitive Services. You go to the Vision Cognitive Services, and basically this is what it looks like. Quota information, tier. So I get 5,000 calls, free tier remaining. Tells me how many I have remaining. So when I did this, I had 4,966 calls remaining, and free tier rest period, 30 days. So it gives you that information. The big thing that you're going to need, though, is you're going to need the keys. So you need the endpoint and the keys. Go to Manage Endpoint and Keys here, and this will give you your keys and your endpoint. So basically, when you connect to Azure, so if you take a look, I can't zoom on this. Anyways, so the endpoint is basically when you connect to Azure, you'll connect to eli-test.cognitiveservices.azure.com. Well, you won't do elite-test, you'll do whatever you created, but you'll connect to that endpoint, and then you'll give a key. The curious thing here, the cool thing here, again, in the enterprise world, they actually give you 2 keys. So the keys essentially act as the password, the username password in order to access the service. And one of the things with any of these kinds of infrastructures is you should refresh the keys periodically, right? So again, any kind of data that gets stored can get compromised. If your keys get compromised, that could be really, really, really bad. You could have hackers do denial of services attacks, do all kinds of wacky stuff. So why they give you 2 keys here is essentially both keys are active at any one time. So what you can do is you start by using key 1. Right? When you create the code, you use key 1. Use key 1 for a while, then you realize you need to refresh the keys, you need to put a different key in there. So then you put key 2 in, since key 2 is still active, and then what you can do is you can refresh key 1. Basically, you regenerate key 1. Then key 1 is a new key. Use key 2 for the predetermined amount of time, go back to using key number 1, which is now a new key. You then regenerate key number 2, periodic amount of time, then switch over to key 2, so on and so forth. So they give you those 2 keys there, so you never have to worry about downtime. If you work with any system that essentially has 1 key, the problem is when you regenerate that key for an amount of time, you're going to have downtime because your systems are going to have the old key. When you do the regeneration process, the old key is going to stop working, and so your system will stop working until you put the new key in, and that can cause a problem. By doing this, it makes it a little better. But it is also a hacking concern. If some hackers are able to get in here and they know how you're doing this key rotation, they may then plug the second key or whatever into their systems to try to compromise what you're doing, and you can't run into issues there. But anyways, this is just how that works. As far as the code example goes, just so you understand the basics here, what I have is I have a form. It's actually form.php, not form.html. What happens is you input the URL into the form.php. It then submits the data back to itself. At that point, it writes whatever the URL is to a data.html file. Afterwards, it then triggers the Python script. Use the exec function of PHP to trigger the Python script. The Python script knows to look at the data.html file to look for whatever URL it's going for. Then grabs that URL, processes this through Azure, and then basically what it does is it dynamically writes the web page for results.html. So let's go and try to look a little bit at this code, see if folks understand what's going on. The first thing, let's come over here, is look at the Quick Start Guide. So the Quick Start Guide for the Vision services is awesome. You can use many different languages for Azure Vision services. You can't use PHP. I like PHP. I know, I'm a boomer. Oh well, that's what I like. Anyways, you can use C#. So again, if you're using the Microsoft stack, you may be using C#. You use Python, what we're using, Java, JavaScript, Go, or the REST API. When we come down here, basically, so you understand how to install this, this is just oh my god, this is just copy and paste, works so well. So you have let's say you have your Ubuntu machine, so you create a fresh install of Ubuntu, and you want to start using this for Azure services. The first thing is you do pip install upgrade Azure Cognitive Services Vision Computer Vision. So this installs all the Python modules that you're going to need for Azure Vision. If you're using a clean install of Ubuntu, you'll probably also actually have to install pip, just so you know. That's the Python installation package manager. Then past that, you're also, once you have pip, you're then going to install Pillow. Pillow is a module for Python that allows you to mess around with images, basically do dynamic image modification on the fly. So obviously, since we're doing vision here, it makes sense that Azure would need that. And then past that, everything else is pretty simple. So in the Python script, you're going to add the modules that you need for Python from Azure Cognitive Services. You're going to grab Computer Vision Client, Operation Stats and Codes, Visual Feature Types, and Cognitive Service Credentials. You're going to import the array, the OS, the stuff from image, sys, and time. So basically what you're going to do is you're going to go here and you're going to click that copy button. Click that copy button. And then you're going to paste it into your Python code. Then down here, subscription key, you're going to hit the copy. You're going to paste this into that Python code that you're creating. It's asking for the subscription key, so you either give it key number 1 or key number 2, whichever one, as long as they're active. It's active, that's all that matters. And then the endpoint, whatever the endpoint they gave you, and you're going to paste that in there. Then past that, we're going to go down here. We're going to authenticate the client. So you're going to copy this. You're going to paste that into your Python code. That actually does the authentication process. And then down here, we're going to tell it what image we want to analyze. So again, this can all be static for you. You can create this statically, just write the Python code and see what the output is. So they just give you an image that they know what it is. So remote_image URL, and they give you an image to point to. They know how that's going to process. When you're actually creating this, you're doing the copy pastaing yourself for the code. You can simply modify this to whatever URL for an image you want it to be, and then run it, and you can see what the results are. Then past that, they have many different things that you can do. So these are all individual blocks of code, so you can mix or match. You can take one, you can take all of them. You don't need all of them. They don't require each other to operate. So once you have everything else, you can get an image description. So basically what this does is it simply prints out basically on the command line when you run the Python, print what the description is. So print the description with a confidence of, so caption.text, caption.confidence, it will print this out. The cool thing is here, and again for Python, you can then modify this to be whatever you want. So this print function here will print out onto the command line. So you run this on the command line, it will print this out on the command line. Well, here's the thing, like for the Python code that I copy pastaed, all I did was I changed this from print to I changed it to basically write to a file.write. So it's writing to a file instead of printing out on a screen. So that's where you can go through and you can just modify this relatively easily. Get image category, so you can print out what the category is. Get image tags, so if you want tags for the image, that's the code you want. Again, copy. You just copy it, you paste it in, right? That's all you do. You just modify this component, you could modify this area right here if you want to do something else. So again, if you wanted to write to a file, if you want to dump it into a database, that type of thing. Detect objects, so if you want to know what objects are in the thing. Detect brands, so it can detect Under Armour, detect Nike, McDonald's, whatever else, we care about that. Detect faces, that's what I showed you with the age and gender and all that kind of stuff. Oh, detect adult, racy, or gory content, if that matters. Do you want adult, racy, or gory content or not? Again, this is no morals here, no ethics here, right? If you're trying to create a competitor to Pornhub, you probably want adult content. If you're trying to create a competitor to PBS, you probably don't. But this is a way to try to automatically scan through. Again, get the image color scheme. So getting the color scheme, is it white or black? The accent color, the dominant background color, the dominant foreground color, dominant colors. So that can print out for you. You can get domain specific content. So you can actually create specialized models for things that you're looking for, and it can spit out that kind of information, get the image type, whether or not it's a JPEG, that type of thing. And then basically in order to run it, again, whatever you've called it, you simply do Python, quickstart-file.py, you run it, and again, it'll print out to the command line or such. So that's basically the example that they give here. Let me show you the actual code. There we go. So this is the horrible code that I created. Yes, I'm an IT guy. I am an IT guy. Anyways, just to give you an example here. So this is that index.php. So this is the initial form that we went to on that first page. So what does the computer see? That was the title up at the top. Then we start PHP. So basically what this PHP for here is from the form down here. So we create the form. So the form action is index.php. So the information given here will be sent back to this form, or this page for it to be processed. Method equals post, input type equals text, name equals URL. So we're looking for text, and we're going to call it a URL. Then we simply do submit. And then down here, I have a hyperlink to Azure result.html. So this is a hyperlink so that we can go and click on the results. So I put in the URL, I hit the submit button, and then submits it to this PHP file. what happens here is it'll print out what the URL is. So I do this as a troubleshooting technique. So if I plug something that isn't an appropriate URL, I know why it's failing. So it'll print out what the URL is. Then it says the URL is, and then it prints out what the URL is. And then URL, so $, we create a variable for URL that equals post URL, so the URL value that's coming in. I then do file, so file equals fopen, the data.html, and I put it to write. So I open the data.html file as a writable file, or die, it fails if it's not there for some reason. I then fwrite, the fwrite function writes to a file, so I write to the file that I set up here, the URL, and then close the file. So I submit the URL to the form then basically sends the URL to the exact same PHP script. That PHP script then writes it to that data.html file. Then down here, what I have happen is then I use the exec. So there's an exec function. So the exec function can actually run commands at the command line. And so what I do here is I simply use the exec function and I do python vision-py.py. Yeah, I know, it's horrible naming convention. It's horrible naming convention, I get it. Anyways, so basically what I'm doing now is after I've written to the data.html file, I'm running that Python script. And so what will happen is that Python script will then grow and grab whatever value I put into that data file, and then it will print out the response that it gets from Azure. So this is setting up all the modules for Python here. Here's the subscription key that I'm using that will be deleted by the time that this is published. Here's the endpoint that I have, so that's how it looks. And then down here, I have file equals open data.html as a read file. I want it to be read, not written to. URL equals file.read, so it reads from that file. It grabs that URL that I just wrote to that file. And then what happens is it prints the URL. Basically, that's just on the Python screen, the command line screen here, just as a troubleshooting routine. And then basically as we go through here, then it's going to dynamically write out the page for me. So when we come down here, so I'm going to file open, so I'm going to open Azure result.html. So that's that dynamic web page that I'm going to open it for write. I'm also going to create a variable for a file, so this is for appending. So writing, if you open a file and write to it, you're going to overwrite. If you use a, you append to it. So if I'm going to be adding to a file, I want to append to it. So initially, I'm going to delete whatever's currently there, and then everything afterwards I'm going to append. Then I'm going to file write, aref equals index.php back. So this is the back button at the top. So if we go here, see this back button? So basically I'm just simply writing that there so I can get back. A file, so a file is appending to the file write. So image style equals max width of 25%. So I want to make sure that this picture isn't too big. Since I'm going out to the internet and just grabbing random URLs, I might get a really big picture and then that might fill up the screen and that makes a horrible demonstration. So simply by using CSS, I simply say I just want the picture to take up 25% of the screen. That's it. So that's what I'm doing there. 25% height auto, and then the SRC. So basically SRC equals the URL. So that URL that I grabbed, basically I just put that here and I do the image. So I'm embedding the image using the URL that's been submitted. Then do a file description. So here, under the image that I've embedded, I simply print out an H3. I print out description. Let's see here, and then from there, because I got the description, this is the code for the description, so I then print out the description. I then print out a file category, so the title for category, and then what I do down here is a file.write. So instead of printing out to the screen, I'm now appending to the file, and it will loop through, and it will give me the category. Then I do a file.write, so I append, I say H3 as tags. This will then loop through and it will do all of the tags. Since this is HTML, I also do a file and do a break. So it goes line to line to line. So what that's doing here is it does tags and then it prints out the first tag and then it loops through and then it gives it a break and then it loops through, prints out the next one, gives it a break, bop, 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 bop. So that's what's going on there. And basically you have the same thing going through with all this stuff. Again, print faces, a file, it prints, the face gender, the face age, it prints, all this different stuff, and then a break. And that's basically how we print everything out to this rather horrible little web app here. Again, the important thing to understand when you're looking at this though is you can copy pasta. You can basically copy paste the code that you're given by Azure. And here I'm printing out to a dynamically created web page. You can use the same thing to basically submit right to a database. You can do the same thing in order to do an if-else, and if the image is of a man who is 40 years old, you can trigger the sprinkler system to turn on, right? This is Python. So now that you have this basic code here, going in here and tweaking the last bit of it isn't that complicated. So I hope this makes sense. I have to get better with explaining code. I really have to get better with writing code. Let me be honest, I have to get better with writing code. But anyways, you get what you pay for. You get what you pay for. And this is on YouTube, so you ain't paying much. Anyways, Azure issues, things to be thinking about. So as I was showing you with those URLs, so Azure can go to a URL, it can grab the image, it can process the image, it can give you results. Remember, public images are public. Just let that sit in for a second. Public images are public. So the important thing to understand here is if you're using URLs, right? So if you create your own, like with what I was showing you, I created a LAMP server on a DigitalOcean instance up on DigitalOcean. If you have images in a data store and you make them public so that Azure can see them, everybody else in the world can see them too if they know that they're there. Right? So if you create a folder that is publicly accessible so that you can have your script feed images to Azure and get the responses back, you just realize if people know where to look, they can download your entire damn data store because, wait for it, it's public. So again, we talk about security. Like, is it cybersecurity or is it just not being a nimwit? A lot of the problems we see in the modern technology world have nothing to do with like what you would really consider cybersecurity, and everything in the world to do with stupid administrators. So if you're going to be having your images be public, make sure that they should be public. Again, pictures of barbecues, pictures of meetups, pictures of things that happen, public events, that's fine for being public. Again, very important thing to think about. You don't want all of the images for all of your employees to be public. You sure as hell don't want, the files for things like your medical patients to be public. And those are some of the things to think about. If you are worried about security, again, you have private images, that's where you should use Azure's data storage in order to submit the images to Azure. So basically you can buy storage within the Azure infrastructure, and then you can point the Azure services to that Azure storage versus to a URL. So be very careful with this. Again, is it security or common sense? I would argue it's common sense. Free service gives you 20 requests per minute and 5,000 per month. One of the issues that I've seen here is I was playing around, and sometimes I would kind of hit the Azure services a little bit harder than I was thinking. So when you think 20 requests per minute, that seems like more than enough. But depending on what you're doing with your scripts, you might actually go over your allocation for a minute, and then basically they time you out. So all of a sudden your scripts are going to stop working, and you're going to think that you did something stupid, and in reality it's just you went over the quota limit. So to be careful about that 20 image per minute quota limit as far as Azure goes. I did a script where basically I wanted to scan a folder and then submit every single image in that folder to Azure, and so I was just doing one image after the other. That's one of the times when I hit the quota. So what I would argue that you should do is if you're going to be submitting numerous images, you should come up with kind of a submission system. So essentially have like some kind of database or something where basically you grab the first image in the folder that you want scanned, you then submit that single image Once you get the results, you dump that into the database, and then essentially you go to the next image in the folder, then you scan that, put that into the database, reset the script, go to the next image, so on and so forth. If you try to scan a lot of images all just in a row, one of the issues you're going to get into is it does take a little bit of time in order to scan these images, 1 to 2 seconds. It's not huge, but again, you dump in 10 or 20 or 100 images all at one time, and basically with the resources on your system, you can bog things down and screw things up. It's much better to have some kind of essentially scripted submission system. So you submit one, get the results, restart the script. Submit the second one, get the results, restart the script. Blah, 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 blah. That would be my advice. So you step through it all. Now, one of the interesting things I did find modern world. Again, here is Silicon Dojo. I try to stay out of the politics. And I really do. Like, again, for Silicon Dojo, just so you understand, I will try to talk about some things that are going on in the modern world that may have political ramifications, and I will try to explain the technology that's involved in what's happening, but I try to stay out of the politics itself. Again, I want Silicon Dojo to be an academic place. I want everybody to be able to come in, and I want them to make LEDs blink. Republicans and Democrats can all make LEDs blink, and believe me, LED hates all of you. It's kind of like being a boss. I hate all employees. I hate all employees equally. Same thing is true with LEDs. LEDs don't like anybody, right? But I think this was kind of interesting that I saw from Microsoft, because companies are now getting more political. So June 11th, 2020, Microsoft announced, so this is coming from the Microsoft Azure website. Microsoft announced that it will not sell facial recognition technology to the police departments in the United States until strong regulation grounded in human rights has been enacted. As such, customers may not use facial recognition features or functionality included in Azure services such as Face or Video Indexer if a customer is or is allowing use of such services by or for a police department in the United States. So I think this is kind of interesting. Again, this is one of those weird things we get into when we start talking about serverless architecture. So if I buy a server operating system from Microsoft, generally they don't have a lot of rights over how I use it very specifically. Generally, they do, but not this specifically. This is kind of curious what we're starting to see with serverless architecture, where these companies are more and more saying specifically what you can use their serverless architectures for, and so this is just something to keep in mind. The other thing that I would say here, which I think is kind of funny, again, not getting political on this, but everybody likes to focus on one thing, again, like police departments. What I find curious about this is I am very interested to find out what happens when both sides of the political equation in the United States realize that this technology exists. Because think about it. What happens when people on either side of the spectrum start going to whoever's rallies, whoever's events, with 50 megapixel cameras and starts just snapping pictures of everybody that they can find? They snap a picture of everybody they can find. They have a nice little GPS, geolocation tag attached to that. And they submit it to Azure, the Azure Vision Services. They start dumping this into a database, and they start correlating their own information. And it becomes a very interesting world. Again, we have been worried about the FBI, or some people have been worried about the FBI and the NSA and the CIA and even police departments, because the idea is this type of service used to be so expensive, so exorbitantly expensive. The only people that could actually use these types of services for good or ill, frankly, were government organizations, right? Billions of dollars. You want to do facial recognition? Put $1 billion on the table. Table stakes is $1 billion. What's kind of curious, again, when you see like on Twitter, like the Sleeping Giants group, they go after companies for certain things, all that kind of stuff. You see folks going after other people to try to get them fired from jobs. I think what's very curious here is when you start looking at services like this, and then you start thinking about how much power this gives individual people. Think about how much power this gives small groups, where you send a small group of people to go out and start photographing events, again, correlating data with other things. Again, anybody can create a database. Anybody can use these services other than police departments. You start doing some interesting things, and I'll be curious to see how this works out at the end of the day. So I think we might actually start seeing a hell of a lot more legislation around these types of services. I'm not really sure what it will matter though. Again, just because you try to legislate a solution doesn't mean it's going to make anything better. So just one of those things to ponder. So beyond that, let's just go over AWS Rekognition a little bit. So AWS Rekognition is Amazon's vision services. Again, a lot like Azure, only harder. Only harder. All right, it's just true. I mean, it's just like I say, Azure is like, I don't know, maybe it's coming from the MCSE world. Again, I have an MCSE. I worked on Microsoft systems for gosh knows how many years. So maybe Azure just made a hell of a lot more sense to me. But again, like I say, I took a look at Rekognition. I was like, it's giving me a headache. I don't have time for this. I have other things I need to do. Okay, so let's go over. Let's figure out where my mouse is. And nope. Rekognition. So this is a Rekognition console. So in order to get to this console, you actually have to create an account with AWS services, and you go look for Amazon Rekognition. So I'm actually logged into my account at this point. I don't think it gives you any private information, just so I can give you some demonstrations of what Rekognition does. Let's increase the size of this, so hopefully in your computer screen so you can see what's going on. So basically right here we have facial analysis. So if we look here, it's a facial analysis. So they have a picture of this nice lady, looks like a face, appears to be female, 99.3%, age range is 21 to 33 years old, is smiling, appears to be happy, wearing glasses, eyes are open, the whole 9 yards. If we go over, let's go get an Idris Elba. Idris Elba. Idris Elba is the name of today. It is kind of weird when you do like education things, like just stupid things just kind of stick in your brain. Okay, let's see if we can grab Idris Elba here. So we're going to do this. We're going to go to copy image address. We're going to go back to Rekognition. We go down here. You can use a URL just like you can in Azure. And then we're going to do go. Oh, URL is either invalid or Surf does not support. Again, they're doing this. They're doing some kind of copy protection system. Not exactly sure what's going on. Okay, let's do the Idris Elba and his wife. Right? Okay, so we're going to do this. We're going to copy image address. Hopefully this is not copyright protected. Paste. Go. Oh, there we go. Okay, this is working. This is what sucks when you have to do like live demonstrations. Sometimes things fail. You're like, why is it failing? Don't fail now. Just accept failure. That's one thing. If you're going to be doing these kind of talks for your own Silicon Dojo or whatever else, you kind of got to be a little spontaneous. You gotta improvise a lot. So when something is taking a hell of a lot longer than it's supposed to take, you can sit here and you can dance and you can talk with people, while the image gives you a little circle. Oh, come on, Azure. There we go. There we go. Thank you, Azure. You're doing what you're supposed to do. Anyway, so basically it shows multiple different things. So we have Idris Elba here, looks like a face, 99%, appears to be male, 99.8%. Age range for this Idris Elba is 25 to 39 years old. Again, when we look at the age ranges, don't think about the precision so much. Think about what you are actually using this for. If you are trying to sell Bacardi, you want to sell it to people that are over the age of 21. That's the most significant thing here. He's smiling, so he appears to be happy. So this is a really interesting thing. So a lot of new computer-based systems are actually trying to tell the emotions of the people that are interacting with the systems. I saw this with Nextiva. So there's a company that does basically online. It's software as a service, but for your entire phone system. Think about Skype, only scaled up, like the Definity of Skype, I suppose. But one of the additional services that they could add on was actually to try to understand semantics, try to understand like the emotional state of somebody on the phone. So if you have a call center agent and they are talking with somebody, that the system can actually start to understand the stress level of the person that call center agent is talking to. And the idea is that you could then trigger events. So if the system could determine that the person on the other side of the phone is getting more and more stressed, more and more angry, it could automatically fire and basically, trigger an event to tell the call center agent to offer the customer, $25 off of their next order. right? So again, these are some of the things to be thinking about with these automated type systems. If you have a customer that is getting angry, like, is there some way to try to placate them or something else? Or are they happy? So again, appears to be happy. Think about this if you're in a retail setting. If you're in a retail setting and you have these pictures that are being taken every so often, so every time like a retail associate gets close to another person, a picture is taken, it's sent off to one of these vision services, and then the vision service can try to determine, does the customer appear to be happy or does the customer appear to be pissed off? So 90% of the people that deal with, Tim seem to be happy when they're dealing with Tim, and 90% of the people that deal with Sue, let's say, are pissed off when they're dealing with Sue. Maybe you need to go in there and give some customer service training, that type of thing. Again, do remember this when we talk about management. This is a tool to try to help improve management. It's not actually supposed to be a manager onto its own. But these are kind of the interesting things that you can do. I think you can click here, and then you see, looks like a face, appears to be female, appears to be happy, not wearing glasses, eyes are open, mouth is open, does not have a mustache. That's kind of weird. That's kind of weird. Why would you say she doesn't have a mustache? Anyways, again, it's some of the interesting things you get out of this. You go over here to object and scene detection. So this basically gives you an example. I'm not going to pull up a different one just because you get the point. So it shows a car, 98% probability, automobile, vehicle, transportation. Shows a human, shows a skateboard. It tags it as sports, tags it as road, tags it as wheel, machine, path, downtown, city, urban, building, town, asphalt, parking lot, blah, 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 blah. You get the point. So it's able to pull this kind of information. Image moderation. Now, one of the things that I see with Azure, or with Rekognition, that I didn't see with Azure, is they actually have this API for the image moderation, where you can actually tie your own things into the image moderation to try to improve the image moderation for your particular company, right? So imagine you have a girl in a bikini, but you have settings that you don't want sexualized images. So let's say you don't want full-grown women in bikinis, you don't want to go there. This gets weird when you say it. Anyways, excuse the examples. I'm just coming up with examples here. For some reason, you don't want full-grown women in bikinis because you think that's sexualized, but if you have a 5-year-old girl in a bikini, you don't really care, right? Let's just say, work with me here. Anyways, so as far as the computer is concerned, a lot of that looks basically the same. So you might be getting that young girl that might be getting moderated when you don't want it to be moderated. So they have their little system here using A2I that's supposed to allow you to go in and be able to help that moderation along. Or again, maybe you're worried about pedophiles. So maybe a full-grown woman in a bikini, you're not worried about from a sexualized standpoint. She's overage, whatever else, but I don't know, you don't necessarily want 5-year-old girls in bikinis on your site because you're worried about the pedophiles. And so again, the same type of thing is true. If both are being moderated out, you'll be able to go in and try to adjust so that the woman doesn't get moderated, but the girl does. I think that's one of the valuable things here. Again, I don't know, they have this weird example. This is a weird example for moderation. I don't know. I don't know why they want to moderate this. Hey, look, it's a nice family on a beach. Don't want you looking at that. The more interesting one here is, again, choose a sample image. So for this, view the content. And over here you can see results, suggestive 81.6%, female swimwear or underwear 81.6%, revealing clothes 62%. So again, a woman in a bikini, do you think that's sexual? I'm not going to go there, but it kind of shows you how that kind of thing works. It shows you the response here. Again, when we talk about JSON, so this is what a JSON response looks like, and then with whatever coding language that you're using, you would then just parse that and to do with it as you will. Past that, you've got things like celebrity recognition here. So this might be an interesting thing. Again, you might be able to use this at like a bar or a restaurant. Lots of bars and restaurants like to talk about who comes in to eat or drink there. It is interesting. Like say if you're in New York or if you're somewhere else, if you plug in your little camera system and it's analyzing who comes in, you might be surprised at what celebrities actually come into your restaurant. And then on the down low, you can try to say like, hey, look at that, Jeff Bezos is drinking beer at my place. You know what that means. Anyways, they got celebrity thing. One of the curious things here is face comparison. So this is kind of cool. So basically you can compare two images and then it'll tell you if the same face is in the other image, right? So you have this girl here and you have this other picture where the girl is with two friends. So the result, so this girl and this girl are the same. This girl is not the same as that girl. This girl is not the same as that girl. If we do the whole Idris Elba thing, let's see here. Grab Idris Elba. Hopefully this works. So we'll copy Idris Elba's image. We'll go down here, we will paste, and then we'll go. Is that going to work? Oh, no. URL is invalid. Oh, these people are killing me with their copyright. Why are these people with copyright? Let's see, copy an image. Let's paste that there. Let's go. Oh, crikey. Killing me. Okay, Wikipedia. Wikipedia will be good. Let me copy that image address from Wikipedia. Go. Most people. Oh God, this is killing me here. Anyways, I will keep this in because this is the kind of crap that you're going to have to go through sometimes. Sometimes you're going to be like, this should be so simple. Copy image address. Just copy the damn image address. Dump it in. It is on the internet. Everybody can look at it. Why are you trying to... Oh, this is... Which image was I using before? Was it this image? NBC News. Can we grab this one? Oh, we are like right at the end of this presentation. And it's going up, go. Okay, there we go. Okay, we got Idris Elba. We got one picture of Idris Elba. Idris Elba. Okay, so Idris Elba and let's see here. Idris Elba. Oh, and there we go. Can we get this? So Idris Elba and I think Chris Pine. It's Chris Pine right there. Come on. Give me Chris Pine. Oh, give me some Chris Pine. I like Chris Pine. What happened to Chris Pine? I actually think he's a pretty good actor. He's a pretty good actor for this generation. Anyways, okay, let's do copy image address. Copy the image address. Oh, and then we're going to paste. And then we're going to go. And go. Okay, it's giving me that darn failure again. Okay, Chris Pine. Well, we're just not going to have you in there, Chris Pine, then. Oh, okay, there we go. Idris Elba and some other folks. Again, this is something that you're going to have to do. Like in the real, like when you're doing these demonstrations live, it's why you should be a little bit more prepared than I am sometimes. I just kind of wing things sometimes. They don't always go well. There we go. Now we're getting this. Now we're getting this done. Okay, Idris Elba. Come on, give me some comparison, Idris Elba. Do a little dance. Do a little dance. Get down tonight. Get down tonight. Get down tonight. Get down tonight. Do a little dance. Yeah, I'm on a crappy DSL connection here. At my home, I have a gigabit internet connection. Here I have 12 megabits per second. Anyways, okay, we're analyzing. Oh, we're doing so much analyzing. Killing me. There we go. We did the analysis. So results equal. This person does equal that person. This person does not equal that person. This person does not equal that person. And so anyways, that's just a bit of an example of the whole facial comparison. So again, that's where I say, like with family pictures or any of that kind of stuff, you can put in like the one image of your great-grandfather or your uncle or, your great-grandmother or your sister or whatever else. And if you have a lot of this stuff, it'll work out for you. So that is basically this seminar for easy computer vision. And again, as I say, Azure is amazingly easy. Azure was easy. Again, AWS Rekognition. Again, if I had given it a day, I'm sure I could have gotten it up and running. The learning curve there was a little bit more difficult. But I really want you to be thinking about this, like how you can use this with your projects in the modern world. Again, when we look at Raspberry Pis, with these little, very inexpensive Raspberry Pis, you can get a $10 Raspberry Pi or an $80 Raspberry Pi. You can connect a camera to it. And so something to be thinking about is how could you position cameras in your facility to offer services. Again, for digital displays. If somebody walks by, it triggers, takes a picture, looks at what their color scheme is, and then shows images of models in the same color clothes or in the same accent clothes, right? Same place in the color wheel. Again, for security services, if everybody is wearing the same uniform in your facility, just a very simple light touch security thing could simply be if somebody walks by and they have the color that they're supposed to have, the door is automatically unlocked. If they don't have the color on that they're supposed to have, the door isn't automatically unlocked. These are some of the little things that you can do with these kinds of services. Also, again, I think about this from a management standpoint. Look, Silicon Dojo is a real business. I really don't want to get sued. I know whenever I talk about employees, everybody talks about the creep factor. Oh my God, you mean you'd spy on employees? It's more like I'm trying to make sure the employees don't do something horribly stupid. I've had employees. Oh golly. The stories I can tell. And so again, if I can have a single pane of glass to show me where there might be problems. If my 19-year-old assistant instructor is spending a hell of a lot of time with a 16-year-old student, just want to have a little conversation and remind everybody the term of fraternization, and that is not allowed in Silicon Dojo. These are some of the things to be thinking about. And again, my idea with this is it just gives you more information to make more human management decisions. One of the big problems we're running into in the modern world is a lot of people essentially want to hand off their management to these computers, and it's very important to understand that is not what I'm arguing here. I'm saying that you should be using this as additional forms of information so that you or your managers can make better, more informed decisions. You're not handing the damn decision over to the bot. Because when you hand the decision over to the bot, then you have somebody that's been on your platform for 12 years who gets 3 community strikes in 5 months for not breaking the rules. And then they start saying really, really nasty things about your platform. I'm just saying. That's what can happen if you hand your management over to bots. So anyways, those are some things to look at. And so that's basically all the seminar is. If you're interested, again, just go over, take a look at Azure. It's pretty simple to set up on silicondojo.com. I will have the notes, the presentation here. I'll also put most of my code and most of the demonstration information. So if you want to build this type of thing on your own, you kind of understand how it works. Yes, I understand I'm not the best coder in the world. I'm getting better. I'm trying to show you the concepts here and what can be done. Not how to be a rock star coder. Of course I'm not going to train rock star coders. I'm sure as hell not one. So anyways, there you go. If you do want to support Silicon Dojo, there is a link down below to help donate to Silicon Dojo. That supports everything that we're trying to do. Again, I'm trying to do free to the end user, hands-on technology education here in Asheville, and also create a system that can be replicatable to whoever else wants to do it. It does cost money. Being good doesn't mean you don't got any bills. Hopefully we're going to be moving to a larger facility relatively soon. That's going to cost even more money, and so any support that you can offer would be good. If I'm helping you get ahead in your career, tossing a couple of dollars in would be pretty nice. But beyond that, I enjoyed doing this presentation for you folks. I look forward to seeing you at the next video, and hopefully here at our Asheville, North Carolina classroom. So I'll see you then.